Yeah, looks like it's recording on my side. So let's just start. Hey, everybody, welcome to the Sustainiacs. This episode is called Urban Machine, which is also the name of a company if you don't know that yet. I am Michael Vincent. I am a Sustainiac. I'm your host. My guest and the other Sustainiac today is Eric Law, and he's co founder, I believe, and CEO of Urban Machine. They're out in the Bay Area, West Coast. Hey, Eric, welcome to the show, my friend. How are you?
Doing good. Thanks, Michael, for having me.
I'm so glad we got on, and this is through um, a friend of mine is a friend of one of your employees or one of your partners there, and we got this hooked up, which is really cool because I'm into all kinds of things sustainable. And I've never heard. I mean, I've seen people doing this type of stuff, but like yeah, our house furniture used to have, or Bauhaus furniture used to have, like coffee tables and stuff like that, built out of, wood from barns in the French countryside and all this other kind of stuff, right? That's not kind of what you guys are doing there, right? I mean, because your thing says robotics for reclaiming lumber from C&D, which is construction and demolition, I imagine. Can you give us the elevator pitch? What are you guys doing out there in the Bay Area with lumber?
Yeah, you got it. We are building robotics for taking the metal out of lumber. So every year here in the US, 37 million tons of dimensional lumber goes to our landfills or incinerators. To give you an idea of how big of a problem it is. So, the furniture folks have done a great job, but it's a very small piece of the problem. Construction generates just way more wood than what the folks have been consuming. And so our goal, and really the challenge of why it's not being reused, is all those nails, screws, and staples that hold our buildings together did a really good job. And so when we take the buildings apart, they're left in the wood. And so our robotics and our scope is to get that metal out, because once it's metal free, then any wood manufacturer can take that dimensional lumber, they can turn it into furniture, they can turn it into architectural facades, or you can do engineered products. You can put it back in the building. It's, you can cut it, rip it, and plane it just like you do virgin lumber.
Wow. That's 37 million. What is 37 million tons of wood waste from construction and demolition are going. So, I mean, this is like, so when they're building, so like building houses, et cetera, all the scraps and all that kind of stuff that are laying around, all that's going, you're counting all that stuff, right? Is
Yeah,
going,
that's
I
about
got you.
10%. New construction represents about 10% of that
Yeah.
number. 90% is the demolition. So taking down old
Gotcha.
homes, gutting apartment buildings, office buildings, warehouses, because we've built with wood for the last 100 and something years all
Yeah.
across the country, and everybody
Yeah.
wants to
No,
take
you're
down
right.
old and build new.
Yeah. I mean, so refurbishment, if you redecorate, I mean, my neighbors just gutted their kitchen and put new stuff in.
Yep.
So you got the cabinet wood, all that other kind of stuff, right? Wood floorings being replaced. See, when I was a kid, we would, my neighborhood was like half built when I was, young.
Mhm.
And so, we would just go and claim the good wood and go build our forts in the forest.
Nice.
But see, we were ahead of our time, my friend. We were sustainable. We were ahead of our time.
Exactly.
But so there's a ton to unpack, and we're going to get into all of that stuff there. Let's get into you as a little bit, right? So from Cal
Yep.
Poly San Luis Obispo, right? I mean, you've been in construction pretty much the whole through your career, right?
Yeah.
Is that
So I have bounced between construction, tech, and merged the two together. So yeah, I started at a large heavy civil contractor as part of an electrical division with them. I was a project engineer out in the field with boots on, building water treatment plant projects and transit systems. And then went from there to a startup, a tech startup that lasted a couple months before our paychecks bounced, which was a great learning experience. And
yeah,
then went to another tech startup that was much better funded. Spent a couple of years there. It is a company based out of the Netherlands, which was a great project to work on.
nice.
And then I launched my own construction SaaS company in 2005. 2006, we launched and ran that for about 9 years before we got acquired by Bentley Systems in 2015. And so that was fun because it's construction and tech together.
Yeah,
And then was at Bentley for a couple of years, and then most recently built an innovation program at Swinnerton. where we focused on bringing robotics into construction to change how we build buildings.
Oh, so you were working on robotics in the construction of buildings prior to that's very cool. So I mean, so you got two, you went from two startups. One was a little difficult. The other one was probably I mean, startups are difficult even when they're incredibly successful, right? I mean,
Yep.
you've been involved in two, and now you're doing the second that you're actually leading, right? So
Yeah, this is
when
the second one I'm leading. Yeah.
yeah, so you're going through that stuff, and you see the jokes, right? You see the stuff like the memes and stuff that show, the life of a day in the life of an entrepreneur, right? You get out of bed and you're just like, yeah, I'm gonna kill it. By noon, you're ready to kill yourself. By 2 o'clock, the world is your oyster, and by 4 o'clock, you're wondering how you're gonna eat the next day, right? I mean, why put yourself through that again?
It's my wife asked me the same question when I told her about this one. She's like, "Really, again?" I think it's an addiction. We connect up. We have groups of startup founders, and we're all doing this multiple times typically. And what's cool about it is the change actually gets implemented. Large companies, they have their cadence. They are their aircraft carriers. They go in one direction, and they
Yeah.
do their thing, and they serve a purpose. But you can't change them. There is no way to drive change, despite their marketing teams, and we're innovative and all this stuff. It's if you want to actually drive change, it's got to be a small team and it's got to be a startup.
And I don't disagree with you. And I think there's a lot of those companies that try to um, that recognize what you're saying, right? That I mean, it takes a long time to turn an aircraft carrier. I mean, a long time,
Yeah.
and they recognize that, and they get involved with these accelerators, right? I mean, I've been involved in accelerators at other startups, et cetera. And it, I get it. The idea is to try and find new technology, support what is going to support that company, et cetera, right? Or the mission that may be there, sustainability or whatever. But not a lot of them actually adopt what they're those accelerators are producing. Is Were you part of accelerators in your last two, or in this one here? You're just rolling, right?
We're just rolling. So the last one was
Gotcha.
bootstrapped. Venture capital wanted nothing to do with
Yeah.
construction tech back in the early 2000s after
Yeah. Yeah. Yeah.
dot-com
Yeah.
bust. This one, we are venture backed. We had a great team behind us. We've closed a pre-seed and a seed round. And we're not even 2 years old yet. So
Oh,
we're
wow.
screaming right along.
Wow, that is really awesome. The other thing that I saw in your background that I kind of wanted to, hopefully, I mean, it seemed like something that I would like to highlight, because I like to see people giving back and doing certain things. And just looking briefly at the service, the Sustainable Lafayette Board had like a little statement there that kind of, what is that? And you're involved in that still, right? It seemed like it has a really good social purpose, right?
Yeah, so that's a volunteer project in our community, Sustainable Lafayette. And our goal is to kind of educate and evangelize more sustainable practices for the city, for the residents. And one of the projects I'm involved with on that is actually building a bike path to connect to our high school,
Oh, nice.
which is pretty cool. A bike ped path through a pretty busy street and crossing a major highway. So not everybody has to drive to that school. Give people an option to get out of their cars. And that's the cool thing about this project Urban Machine. It combines sustainability, its technology, and its construction.
It
Um,
is. So is that why lumber? Because I mean, I saw that your background. You've been in construction, and you're a tech guy, and I can see and you can hear obviously the passion in your voice. It's quite obvious. And you're going through two different startups, and now the second one of your own, trying to make this stuff happen. Why old lumber? Why was that the one?
yeah, so when I was at Swearton, we were researching waste streams for a sustainability initiative. And we were taking a look, what happens to steel, concrete, glass, all these different materials that come out of our projects. And what we found was lumber was the only structural building material that was not getting recycled. Both steel and aluminum and concrete have recycle paths, and lumber was the only one that was going to landfills and incinerators. And so we started to look at this deeper and say, okay, why aren't we recycling this, high strength natural material with a real low carbon footprint, right? What is it that's preventing that? And that's where we learned about the metal problem.
Yeah, exactly. And so, all right. So, but before we get into that metal, because that is really, really cool. I've seen the videos, right? And I've spoken
Yep.
with George, who's kind of giving me a heads up, and just the brief talks with her, I'm not a tech guy, but I'm a tech and data geek wannabe, right? I know enough to speak to you long enough that eventually, after probably the second beer, I'm in way over my head.
Perfect.
Is right, but I'm still listening and interested as hell. I'm going. So you're telling me that one molecule in my finger could be a universe? You know, I'm that kind of guy. Really, I really geek out over it. I wish I explored it more. But so, in the Christmas tree industry, right? I learned from some people that getting the Christmas trees, right? The live Christmas trees is actually better than the fake ones. And not just because the live ones aren't plastic, but because of the efforts in the farms that are out there, there wouldn't be as many trees built because of that use, right? So you're not against harvesting trees sustainably,
Nope.
right? You're just we've already got this stuff, so why aren't we using it? Why are we destroying it and polluting the planet with that incineration? Is that right?
Exactly. Incineration and burying it. And the other challenge too with harvesting the trees is there's actually a large carbon footprint because
Mm,
typically they're coming, here in the US, they come out of the Pacific Northwest and Canada.
right.
You harvest them, you truck them to a mill. The mill cuts them up into 2x4s and dimensional lumber, and then you're train or trucking it across the country thousands of miles. And the big carbon burn is actually drying that wood in the kilns, right? So it's a pretty intensive carbon process.
Yeah, that those are
Uh,
really good points.
just to get that virgin in. And it's like, okay, if we went through all this process initially, and then we're going to throw it away after 20, 30, 40, 50 years, whatever the lifespan is, that's kind of a waste. Um,
Wow.
and so what we're really looking at is let's close the loop on wood. Wood's got a great green story to start with, but then its end of life isn't so good right now. And so we're hoping to change that. Because both steel and concrete, not the best recycle paths, pretty energy intensive, but they're not going to a landfill, right? They're not sitting in a hole in the ground.
Yeah, the alternative is better, and I did a show. My last show I did was with, or yeah, the last show I did was with Anjali Mehta. She's a freelance science writer for Reuters, and she kept using this saying: don't let perfection get in the way of good." Right. So
Yep.
we've got to make these and get better at it. Right.
Yep.
So that is really cool. So is the dream someday that buildings will be like I could build a house 100% out of reclaimed wood, or is it to supplement? Is that the real market? What's the addressable market that you guys are going after?
Yeah, so we're focusing on really two direct applications for reclaimed lumber. There's the old growth stuff, right? Tight
Yeah.
grain, rough sawn. Architects love it. You can use that, for siding, facades, buildings, real architectural uses.
Right.
So we want to definitely save that and focus on the architectural side there. And that can go into your office buildings. It can go into any building an architect wants to show off wood and its warmth.
Right.
And then we've got kind of what we're calling the 0 to 60 year about wood. So it's not quite the same quality as that old growth. It doesn't have the architectural appeal, but it's really structurally strong and good stuff. And so we believe that'll go into engineered products. Think about like mass timber products. And so we're doing some research on some dowel laminated timber and nail laminated timber products. And you could use those panels to build houses, apartment buildings. One of the things that people don't realize is wood is still the predominant structural material for residential construction,
Oh yeah.
single family and multifamily, right? And we got to build more housing. And one thing that most people don't realize is our forests aren't infinite. They're pretty much tapped out in terms of capacity and growing trees and producing them. And so if we need more housing and we need more wood for that building stock, we're going to have to reclaim it. There
Yeah.
just isn't that much more land to grow forests on and harvest big tree farms.
I got you. So it's not necessarily that you're trying to reclaim and pull out. I mean, you do this, right? But I mean, it's more than just, hey, let's get all the 2x4s and make sure they come out as structurally sound 2x4s for the next, like there'll be a portion that can happen to, I would imagine, right?
Yep,
But then you're also using stuff for then, like you said, the engineered wood and stuff like that can be used out of it. I got you.
exactly.
So basically, every piece of wood that comes out of a demolition or scrap out of construction can be reused in some manner, is what you're
That's
saying.
the goal. Yep.
Gotcha.
Yeah.
And then the thing that is really that keeps that out is the inability up until this point, because you just solved it, is to efficiently and cost effectively remove those metal objects, because there's several different types that could be in there, right? To effectively, so that can then be reprocessed, because otherwise you can't do it, right? So it's kind of
You
like
got it.
plastic that still has labels on it, right?
Yep. Exactly. You got to get the label off. Yep.
So, are you able to talk about the technology and kind of lead us through a piece of lumber comes in and how does it come in and come out the other end? Can you talk to that a little bit without
Yeah,
giving away too much secret sauce?
yeah, absolutely. So we have the first step is an in-feed station, and that's actually got some people operating it. And what we're doing there is we're going to take off, your big structural fasteners, electrical boxes. These are large items, but they're low volume items, right? It's typically, 1 out of 10 pieces has an electrical box on it type of thing.
Uh,
And because these pieces are so varied in how they're fastened on, right? Some are bolts, some are hammered on with the little pins, some are nails or screws. That's what we're going to use some people for. And then once those big fasteners are removed, then we feed it into our machine where we do a brushing application to take off any light surface contaminants and get the material clean. And then we feed it into our robotics that actually goes after the nails and the screws and the staples, which are the high volume, highly repetitive fasteners.
so, so this like two hands it goes out and grabs a drill and then takes it. It's not.
think think of more like a nail puller, right? So think about like a claw meets a nail puller, and four of these
but
hit the board at the
it
same time.
also spins, right? To take a to take. I mean, are you unscrewing it out of the wood or just yanking it out?
So that's we've done some testing of unscrewing screws. So we actually have a
Yeah.
prototype where we actually pinch screws and spin them backwards.
Wow.
That tool is separate from the one that pulls the nails.
Gotcha. Do you have to keep
So
telling your software people lefty loosey, righty tighty so they get it
exactly. Yep.
right?
Exactly. Yep.
That's hilarious. So it's really interesting because I was watching the videos and what was going on there, and then I think it was a day you guys were testing some like new stuff where you're looking at the grains of the wood to be able to determine pressure and strength and torque and that type of stuff. Is that right? I mean, it gets pretty technical, right?
There's a lot involved. The forces are pretty severe. Pulling out a 16 penny nail that's bent over without breaking the wood requires some careful application of the forces in the right place and then doing it quickly.
Yeah, but somebody's got to hold the piece of wood and then somebody's got to pull it, right? And I know how hard that I've been in construction. I've hurt myself many, many times. I've slammed my thumb with a hammer. I've done it. I've had a nail go in, hit a knot, and come back out through the meat of my hand with a nail gun. I've done all,
Yeah.
and then it melts in because the plastic's there.
Yeah. Yeah.
Yeah, that's no
Oh,
fun. People don't
oh,
understand
ouch.
that's bad. It's not just a nail in your hand. It's also got hot plastic that melted in there.
Uh-huh.
It's a little rough. So I mean, that's what I'm saying. The torque and everything is just unbelievable, right? How long did it take to figure out these things? And you're still tweaking it, right?
Oh, yeah, absolutely. So we're on our fourth generation of hardware. So in
Wow.
just
And
under
you're
two
less than two
years,
years old.
yeah, less than 2 years old on our fourth generation of
Nice.
hardware. And we have learned a lot since we first started this. A lot of it is testing, measuring, evaluating, building, testing, measuring, evaluating, and building again, which in the hardware industry is expensive. Software is pretty cheap, right? If you learn something, you go write some new code and you update your
Yeah. Yeah.
software. But on the hardware side, the engineers come back and they're like, yeah, we got to go buy another $20,000 XYZ. And you're like, oh, okay, we got to do it. We got to get better and faster. We burn up a motor and it's like, ooh, that was expensive.
That's amazing. I mean, so I mean, when you start thinking about what you guys are doing with this software and the recognition and seeing it and getting so precise to nail these things and pull it out, it's really, really quite astounding. I mean, you have to marvel at it sometimes, right? If you're not even patting yourself on the back, because I have bent a nail. I was taught to hit it twice. That's it, right? I had a
Yep.
big Eastman blue hammer that I used when I was in construction. I did rough framing, right? And you
Well, yeah,
tapped it to
yeah.
set the nail, and then one swipe, bang, it's in. If you hit it a third time, the job foreman, the guy that I worked for, would
Yep.
make you take that nail out and throw it away because it's too hot. It's going to bend. It's not structurally sound in his mind. I think he's nuts, but that's what it was. I think it was more just efficiency. Tap, bang, even with a hammer, right?
Yep.
But plenty of times I went tap, bang, and hit it a third time, and it bent over, right? So you got this kind
Yep.
of S-shaped thing, but you bang it all the way in there, so it's almost below the surface.
Yep.
Are you yanking those out too?
We're digging down underneath into the wood to go get that 16 penny framing nail.
Is somebody calling you? Say, hey, Eric, come over here and yank this one out. Or the machines are doing that.
The
The
machines
robotics
are
are,
doing it. Yeah, the
that is
robotics
so
are doing it.
with minimal degradation
Damage.
of the wood too.
Yeah, we just dig a
That
little bit
is
around the head to get underneath it with our pulling mechanism, and then it pulls it out.
so if you got so is it how quick and efficient is, I mean, like you got like just a 2x4 and say there's like, you know, 3 or 4 screws, a couple nails bent over, and how quickly does it work? I mean, is it slow process, or is it just like is it like the robots that you see like painting cars that I used to see those commercials, like zip, boof, boof, spot welders that are
It's
doing this type of stuff?
it's more like the auto ones. It's racing along quickly. It's
Really?
typically right now. I think we're doing about 4 to 6 seconds per fastener is what it
Oh
takes us
wow.
to go for the arms to go grab it, pull it out, and then to move on to the next one. And we have 4 end effectors in each cell cranking away. So it's we've got some pretty high targets to hit in terms of unit economics. We got to move a
Yeah.
lot of material to be successful.
Yeah. I mean, are you there? Is it economical to use it? Is it are you there yet?
On the large dimensions, so one of the things that's
Yeah.
interesting about wood is if you take like say like a 4x12 for example, you
Okay.
know, it's got the lowest number of fasteners per board foot
That makes sense. That
compared
makes sense.
to a 2x4.
Yeah.
It's also one of the most valuable pieces of wood, in our span of wood that we claim compared to a 2x4, right? So the 2x4 has the highest number of fasteners per board foot. So it's the most expensive to clean. And then it's the lowest value piece of material out there.
Right.
And so our goal is to get our machines to the point where we can compete with virgin lumber for 2x4s, which is, it's a high goal. So we're there on the four by
Okay. So
12s.
that's the lofty goal. That's the
Exactly.
gotcha.
You got it.
Yeah, because that big beam that's coming through that's got the value, right? Because that's got more applications for it. It's nice structurally, and like you said before, interior designers, not decorators, but designers, the ones that are closer to the architect, they're going to love that type of stuff, right?
You got it. Yep.
That's got value. It's kind of like in plastics. I'm in plastics, right? People want ocean bound or ocean plastics certified because it's easier to market. It's more valuable in people's minds. So that's what they want over recycle, just plain recycled plastics, right? That's really cool. What's the craziest thing? So are you taking live stuff right now? Or are you still testing with your own stuff? Are you taking stock live and producing and selling right now?
Yeah. So we have demo contractors giving us material
Cool.
that we process. We bring in truckloads of demo wood as our engineers need it. Our volumes are still low because it's still testing on the machine.
Yeah.
And then we sell the clean wood and the customers for test batches.
What's the
So we've actually,
craziest thing you found in a piece of wood? When has Jory ever gone, "Hey, Eric, come here and look at this. You can't believe what we found."
so not so much Jory, but the engineers do it.
Yeah.
And it's these threaded, what the heck were they? They're holding wires from suspended ceilings. And so
Oh,
it's threaded on one end, but then it's kind of a flat smushed head with a hole in it to grab the ceiling wires for the suspended grids. That one's pretty good. Or these, it's kind of like a nail with a flathead screw, and it's got a mild spiral on it that we found in some MEP
oh,
hangers
wow,
that were
wow,
holding some 1960s MEP hangers. So people have used a
interesting.
lot of different fasteners over those 100 and something years that we've been building here in the U.S.
I've eaten at a couple of the older restaurants in the Italian neighborhoods of San Francisco, and some of them were built, when they have the kind of, I don't know, they had like mazes of concrete walls, right? So that
Mm-hmm.
no table had a direct line of sight to the front door, and you can imagine why. I'm from back in the day type of thing. It'd be interesting to see how many, like, if you pull a bullet out of one of these things, right? I mean, do you guys try
So
and trick the machines? Have you ever, I mean, you're testing the machines to see what they can do. Have you putting anything crazy in there to try and trick the machines to see if they can do it or
pretty
not?
much, every load of wood we get in has something new at this
Yeah,
point,
yeah.
right? It's like, hey, we found this project that they're taking down with this hair. Oh, we haven't seen that one before. It shows up in the shop, and we're like, ooh, here's some new fasteners.
Well, I mean, that's true AI, right? That's what it is learning and teaching the machine and the software something new all the time over and over,
You
right?
got it. Yep,
That is
continuous learning for a machine.
so I get the mission and what you're doing, and I understand the sustainability, et cetera. And so walk me through why not just, you already got the people that are taking out the big stuff. Why not the small stuff as well? What is it, because eventually you're going to be able to do it at scale, or why not just have a bunch of people ripping nails out of the stuff?
Yeah, so the economics doesn't work out. Two things: the economics doesn't work out because right now the reclaimed lumber folks kind of go after the super premium products. Think about your barn wood, your wood mantles, historic buildings they're taking apart and reclaiming it. Because one, who wants to pull nails 8 hours a day, 40 hours a week,
Right.
right? It's brutal. It's hard on the body. It's just mind-numbingly rough work. So you can't get people to do it, and then the economics doesn't work. So you really have these niche companies that are, probably most people guess probably about 1% of wood gets reclaimed in the U.S. when you look at the barnwood folks in their industry.
1%.
Yeah,
That's good. Most people just burn it in their backyard. You're allowed to burn in
exactly.
many locations. I'm sure there are places you can. It probably, if you're in a condo in downtown San Francisco, you probably need a burn permit, or probably can't even get one. But I mean, I live in Tennessee, man. I could burn my house down if I wanted to.
You can burn it all, right? Instant release of CO2 and some smoke into the atmosphere, and you're cooking, right?
That's what America's all about, my friend. Throw some beef on there, you're good.
Yeah, and we do burn wood. So what's interesting is in Europe, most of their wood gets incinerated for cogen plants. So they get electricity and heat out of it.
Oh, okay. Gotcha.
And they're actually looking to get away from that as well because of the CO2 impact.
Of course. Well, I mean, wood is a renewable energy source. That doesn't mean clean, people. Renewable doesn't mean clean.
Yeah, exactly.
I mean, fossil fuels technically are renewable. It just takes a long time.
Yeah. Need some more dinosaurs to decompose.
Yeah. At the rate we're going, in about 50 million years, somebody's going to be using us for fossil fuels.
Exactly.
What's going to happen? So who are the target markets, right? In plastics, there's different types of levels, right? Some people want post-industrial. Some people want post-consumer, right? Where is there different levels of where you get your lumber from that are valuable in the market, or has that market not really even developed yet? It's such a blue ocean.
So we're building it. And so those sources, so our goal is to get as close to the source of material. So for us, that's a building, right? So if you have a commercial demolition contractor taking down an old, say, 1950s warehouse, we actually want to come on site and clean the wood after they deconstruct or disassemble the building. Because as soon as you start hauling that material in dump trucks, which is typically what's done, it gets damaged, the fasteners get more bent over, wood becomes lower grade, it becomes a harder problem. Yeah. And so our first target is, hey, we're going to come to a job site, we're going to clean the material up there, and then I can truck it to the next customer on flatbed trucks like normal lumber bunks, and it's metal free, ready to go. So our equipment's actually going to be portable. Then the second source. Go ahead.
No, please.
Then the second source is the material recovery facilities. So this is where your residential contractors take their pickup trucks and your smaller commercial guys go and dump their wood, and you get the debris box folks. Because obviously we can't show up at houses and small apartment buildings, small offices with a 90-foot long machine on two 45-foot trailers.
No.
And so that's our second place. And so that's our kind of our lower grade collection point. But they're centralized, right? You have these centralized collection points that we can operate at on their facilities, separate out the wood from that waste, and then we can clean there and truck it directly off there. So we're actually going to be starting some pilot projects with those folks this summer.
So wait. So you're taking machines to the demolition site or to the construction site, and it's operating there. So okay. All right. I imagined you guys were bringing in truckloads of stuff that's piling up in a warehouse, and somebody else is bringing it into another warehouse and spitting this through. I guess that's part of it too, right? With the other collection sites, I would imagine.
With the other collection sites. So we tried that initially. That was our first business plan was, hey, we're gonna have these big warehouses, bring all this material in. And we're like, whoa. And when we started having dump trucks dump in our warehouse, we're like, oh, this is a big disaster. There's material going everywhere. It's getting damaged. Let's how can we do this better?
Said, I'm going to be late for dinner. We got to change the business plan. Yeah.
Broke a machine, lumber slid into one of our prototypes. We're like, we got to try something else. And so that's when we decided to go with the mobile one and go towards the sources, right? Because the closer we can get to that source of material, the less trucking, more efficient we are, higher quality the material is.
Absolutely. And less trucking, and not only volume, because you can then stack it and densify it and much more, the volume weight metric is much better, right? But also
Oh yeah,
you're taking out legs of transportation, right? Because you're going from this right to another customer is going to use it instead of
exactly.
maybe to another warehouse or something like that. Yeah, that is really 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 interesting. So what aside from what is the value that is getting that the demolition company or the construction company is getting on this? Is it data? Is it carbon reduction emission credits or what I imagine all that stuff comes into play, right?
Yeah, so all of it and cost savings as well, right? Because the demo folks, they got to smash it up, they got to truck it to a recovery facility or landfill. They're paying a tipping fee. Typically the cost to haul material and to dispose of it here in California runs about 10 to 15 cents a board foot to go throw it away in a landfill. When you look at
Yeah.
tipping fees and trucking costs and all that. And then, typically on your building permits, you have a diversion requirement that says, hey, you got to keep so much out of the landfill. And then if you're going for like lead credits, you can't throw it in a landfill. If you start off by taking your existing building and throw it in a landfill, you're in a big hole on your lead credits. It's going to take a lot of solar panels to offset burying all that material that came out of the previous building.
Yeah, right.
Um,
That's right.
and so if we get involved, you're reclaiming the material and you can even use it back in the new building, right? If you're taking down an old warehouse on a site and you're going to put in, say a multi-tenant apartment building, you can reuse that material in the new building and you get a lot of lead credits.
Now that's a really good point because in I'm sure in San Francisco and many other cities where I've lived before, like you got like you can get grants for refurbishing an historic house, right? Like
Yep.
in Chicago, they have those neighborhoods where you can't do certain changes to houses or they have to be done again in the same style, right?
Yep.
And so taking that wood out, cleaning it as you can, and then putting it back in would be a huge benefit using these type of machines. Are you going to
Absolutely.
sell these machines or are you just going to keep operating them yourself?
Yeah. So our roadmap is we'll operate them initially. We got to get the field trials. We got to work the kinks out of it. It's a hardware software solution. We want our engineers to be able to resolve the issues as quick as possible. So we'll operate them. And then at some point, we'll start leasing them and getting them out to the market, let customers operate them, and then eventually be selling them. So once they're nice and stable, it's got the Staples Easy button on it. You can just hit it and run it. Then we'll start leasing them. So that's about our 5-year roadmap for the technology.
Gotcha. That is really, really interesting. Do you see, I mean, you're obviously always thinking and very, very creative. Do you see this, what you're doing here is advancing robotics and having applications in other places? Some of the things that you guys are getting these robots to do?
Yeah, absolutely. We've got a roadmap looking at, so we're focused on clean dimensional lumber right now. So we're
Uh-huh.
avoiding the lead paint and the asbestos and all that stuff.
Right.
Eventually, we want to automate the cleaning of the dirty wood because that 37 million tons is just the clean stuff. There's about an equal amount of lead
Oh,
painted wood out there.
oh, really?
Yeah.
I thought I
Think
ate
about
all the lead paint off of the wood when I was a
no.
kid.
The military and Department of Defense has got lots of buildings that were all built, for World War I and World War II, all coated in lead paint because it was, a good thing back then until we learned that lead's not a good thing. So there's all these older building out there.
Keeps it. It's a radiation barrier. I mean,
Yeah, exactly. Served its purpose. But now we got to clean up these old buildings. So yeah, we want to take a look at the hazardous materials side. We want to look at sheet goods, right? How do you recycle plywood and OSB and all these sheet goods coming off of buildings as well?
well, that's a
And then
totally different dimension, right? You're going to try and keep those. So, is it more? Let me ask you that: is it more valuable or is it more economically feasible? What is the goal with a piece of wood when it comes in? Does it depend on what the type of piece of wood it is? Or does it depend on offtake agreements that you might have, what you're going to do with this load of sheet wood that you have right now, right? In other words, is there different instances where it's better economically for your company to try and save that piece of sheet wood or just destroy it? Just take the stuff out, run it through there so that it can then be just, made into chip for engineered wood.
Yeah, so we're just purely focused on your standard dimensional lumber and glue lamps right now. So 2x4 up
Yeah.
through 6x18 is what we're supporting.
Okay. I got you. Gotcha.
We're
That
not
makes
touching the
sense.
plywoods because the form factor is totally different, right? You could have a sheet of plywood that's a full 4x8 sheet, or it could be
Yeah.
2x3 or 1 1/8, or I mean, it can be all different dimensions, right?
Yeah. And they're usually not what they say they are.
Yeah, exactly. The nice thing about dimensional lumber is it has a consistent cross section, right? We know a two
Yeah.
by four is somewhere between an inch and a half and 3.5 to two
I
by
love
four.
that.
The older you get,
Somewhere
right?
between this and that is what it is. Yes. That's
But it's a
exactly right.
rectangular cross section, and the only real variable that's infinite is the length, right?
Yeah. Yeah.
Because they're all
Yeah.
different
It,
lengths. And
it certainly
so,
is. But do you have, but what I'm saying is this, do you have customers coming to you and saying, listen, I want this type of wood and I'm going to use it for this. And therefore you kind of match that up with a source and then process it accordingly for that offtake. Or are you processing it for what your mission is or whatever or your economics are, and then selling it to whomever may want it? In other words, can I
yeah,
contract you and say, I want this?
if we have the raw material for it, absolutely. So a lot
Gotcha.
of times a mill may be involved. So we've got some milling partners that we work with that are great. So we can take those larger dimensions and we can cut them into smaller dimensions, right?
For the
Uh,
mill.
for that the mill can do that. And then they can sell that to the customer. So we've had some architectural folks come to us and they said, "Hey, I'm building a ceiling grid. Here's the dimensions of the pieces I need. I need it to be, for the most part, knot free or minimal amounts of knots. They'll give us kind of a quality spec, and then the mill will go take the clean, larger dimensions and rip it into the smaller pieces we need for that client."
Amazing. Amazing. So is there waste wood in production, like a furniture store or at mills or something like that that could use this type of thing, right? Where they've built this thing and now, okay, now it's waste. It doesn't work.
So typically they don't have metal in it. So the cutoffs coming out of lumber mills, engineered wood
Yeah, they
folks are
don't have any
typically
metal.
no metal, but it's lots of short pieces. Is the challenge. So that's a little bit different problem. There's actually another company up out of Canada that we're chatting with,
Oh,
where
gotcha.
they're going to take all these short pieces, whether it's from us, because we're going to end up with short pieces too, and they want to turn them back into long pieces at scale. So essentially
Oh,
finger joining it all together. And so there's other opportunities to say, okay, we got a truckload of short blocks. Well, we send them over to this company and they essentially glue them all back together to get long pieces and then put that back into the market.
wow, that is very cool. So, Eric, um, my last really what I'd like to get out to the people is the impact of what you're doing. Right? What is the total, if you have it? What is the impact? You talked about 37 million. Was it pounds or tons?
Tons.
Tons a year,
Tons.
and that's just clean. And that's just the clean wood, right?
That's
That's
clean dimensional lumber. That doesn't include
dimensional
plywood
lumber.
and cabinets and siding and all that. We're about half of the problem was just the dimensional lumber.
That's unbelievable. And that is somewhere in the neighborhood of an $18 billion addressable market, right?
Yeah, if we can capture half of that, if we can recover half that material, it gets us to about $18 billion a year.
Half of that is about 18 billion. Wow. So you're freeing up a ton of capital, right? By doing this. So there's that impact. What is the addressable impact if you hit scale? What is that impact of on the environment? Do you have that, or do you know on the carbon footprint?
Yeah,
Have you gone that far to calculate that stuff?
yeah. So we took a look at it. A cubic meter of wood is roughly a ton of CO2. And so
Wow.
when we looked at the environmental benefits of reclaiming this much material and putting it back into the ecosystem, if we hit if we take that 50%, it's equal to about 4 million cars a year, taking 4 million cars a year off the road.
Is if you hit your target of the 37 million tons,
Half of the 37 million
half of the 37, wait a minute, I've got to write this down. Half of the 37 million tons is equal to 4 million cars
every year. Yep.
annual. That's unreal. So in that calculation, when you're looking at that, is that are you calculating the fact that you're not cutting down a tree and therefore that carbon sequestration is still there, or is that not even included yet?
Yeah.
Or
So
is
we're
it
just
shouldn't
purely,
even be included?
yeah, we're just looking at purely keeping the carbon. So when you take that we're looking at a reclaimed tree and going into a new building and staying out of the air. So essentially, instead of incinerating it or the slow release via landfill. So if you bury the wood, it slowly releases the carbon. So the goal is to keep it stored up. So it could be keeping that virgin tree in the forest, or the key goal is keeping the carbon out of the atmosphere. And so that's how we came up with that. So it's a real high level, just napkin sketch where we looked at, hey,
Yeah,
if
no,
we
that's what I'm saying is it doesn't, I mean, they're impressive numbers and hopefully people understand this because it is incredibly impressive, but you're not even including other impacts
supply
that are
chain
positive.
and trucks and oh yeah,
Well,
there's
that's what I'm saying. So you're not
yeah,
even including the replacement of the virgin wood, right?
yeah,
Wow. That, I mean, that's got to be huge. You got to at least double that impact, I would think, at least, right? If you're going to,
it's pretty massive. Well, another challenge too is we could be replacing steel or concrete, right? Because the customer could choose and say, hey, instead of doing a structural steel stud building, I'm going to use these Dow laminated timber panels over here that are made with reclaimed wood, and that's phenomenally improvement, right? If we go up against steel.
that's unbelievable. Yeah, yeah, yeah. That's awesome. Eric, it's really, really impressive stuff. I'm really impressed with what you guys are doing. I love it. I love anything sustainable. And I love the fact that you're doing something that is a sustainable business model as well, right? And that's kind of my thing is I listen, I'm not against NPOs and organizations and cleanups and all that kind of stuff. Absolutely has to be done.
Yep,
But for a reliable and growth in sustainability and bringing that true circular economies into scale, it has to be a business model that works, right? It can't rely on donations for it to
absolutely.
really, really be a massive impact. And I love what you guys are doing. I applaud it very much. I hope you guys have tremendous, tremendous success in the future. Eric, where are people going to learn more about what you guys are doing there?
Yeah, hit us up on urbanmachine.build is our website, or you can follow us on LinkedIn. That's when Jory posts all of our updates and videos and latest and greatest about us. So follow us there. And this year we're focused on getting our first two systems out the door. So we're still a lot of engineering work, a lot of testing, a lot of development. And then next year we'll start our expansion to about 6 different markets. So we're going to start to move to different cities with about a dozen machines in 2024, and start to grow
That's
this out of
tremendous.
the Bay Area. And yeah, just if anybody wants to talk about wood, reclaiming lumber, either taking down a building, building a new one, reach out to us. We love talking to architects and engineers and owners who want to do this and join us on this mission, because it does take the whole ecosystem, right? We need the demand for the material, and then we need the source. And we're going to connect those two together and deliver on it.
Yeah, you really do. And man, it's tremendous stuff. Yeah, people check this stuff out and support. I mean, check out anybody who's doing sustainability because, like you just said, Eric, you need everybody. People need to support this in order to get it to go, right?
Yep,
And the more people who support it, the more volume starts going through it. The unit of economics start to get better and better and better and becomes cheaper and cheaper and cheaper and cheaper. And pretty soon, you don't need virgin wood,
exactly. Well,
right?
so to put that 37 million tons into perspective, it's about half of what we log from our softwood forests on an annual basis here in the
Okay.
U.S. Right? In the
So
U.S., we're a net
your goal is
quarter.
if is a quarter of that.
Yeah,
That's a massive amount,
it's
25%.
and when you look at these sustainability problems, back to your comment about it's got to be a business model. These problems are massive, right? If you look at everybody at home trying to compost their food waste and stuff like that and CO2 emissions, it's awesome. You got to do it, but when you go to the business side of it, the waste coming out of construction and the landfills, the numbers are just through the roof. And
They're through the roof. That's unbelievable. I mean, is there so let's when you get into landfills and you get into stuff like that. So will you eventually or could somebody could go out and start then just okay, I've got this acre of land or whatever it happens to be. I will now start accepting all wood here and then running it through machines or bringing it over to you guys. Do you purchase wood to
yep.
run through this machine or is that something that would happen eventually?
Yeah, so we're actually talking with some folks that are working on doing facilities just like that, where they want to set up just
Gotcha.
purely recovery facilities. Some are focused just on wood, and some are focused on all buildings. So they want to do doors and windows, they want to do siding, they want to do roofing materials, light fixtures. So there's actually a whole bunch of folks that are kind of doing it on the nonprofit side, and then there's some
Hmm.
folks that are actually trying to do it on the hey, we can generate revenue and create businesses out of it. So there's a lot of avenues for it, but it requires two things. It requires obviously people to make drop off the materials right at these facilities on the
Yes,
source side,
that's
and then it
right.
requires people to reuse those material because a warehouse full of material that nobody's buying isn't moving the needle.
No, it isn't. You're absolutely right. It's not, but the point there is that the machine starts to then create ancillary economies and businesses that are
Yes,
going through there, which is job
and
creation and a whole new industry uh, being born. Or, I mean,
it's
there's
local,
kind of that
right?
industry now, but it's more like boutique-ish, right? This brings it into
Yes.
the norm, I guess, right?
Yep. Yeah, it creates
That
a
is
standard commodity that's locally sourced, creates ecosystems far away from the trees to process that wood into new materials.
No, it is tremendous. I love what you guys are doing. One more time, what's the time frame and where do people get in touch with you?
Yeah, hit us up at urbanmachine.build or follow us on LinkedIn. Just search for Urban Machine on LinkedIn. You'll find our page. Follow us on there. And then we post all of our updates in the loop. And then if you want to reach out to us, I'm Eric at urbanmachine.build.
Excellent stuff. Thank you so much, my friend. Peace and love, everybody. This has been the Sustainiacs. Catch you next time.
Awesome. Thanks, Michael. It's a pleasure.